All right. Hey guys, thank you for joining our session. We have 75 slides to go about Kubernetes, so all your attention for here. We have just 20 minutes. Just kidding. So, hi everyone. My name is Alexei. I'm the CTO and co-founder of Zesty, and I'm excited to be here with Hagit, our VP product. And in this session, we're going to speak about how Zesty helped Kubernetes customers to achieve efficiency in their cloud and actually save cost in their cloud journey. So a few words about Zesty for those who don't know us. We've been around since 2019, serving more than 3,000 AWS accounts and global customers and well-known names. But before we dive in, let me quickly ask you a question. Can you please raise your hands, those who are familiar with Carpenter here? All right. And keep your hands up, those who actually use this in production already. Great. OK. So hopefully this means that you actually care about stability and optimizing your Kubernetes journey. And this is a good segue to what we are going to discuss in this session. So actually, by looking at the data of our customers and by checking the industry reports, we see that the utilization of resources in our Kubernetes environment is somewhere around 30%. I think we can argue for all day long if it should be slightly higher, lower, but I think all of us can agree that it's still far from being in a good and optimized state. And as a cloud engineer myself, for years, I felt like I live in this triangle of compromise, because there is a great trade-off between stability, performance, and the cost. How much we pay for the infrastructure in order to make sure we're serving our business goals and hitting the SLAs and our goals as a company. So we think this is one of the reasons why customers heavily over-provision their environments. And if you just think about this implementation in Kubernetes, end of the day, we need to make sure that our infrastructure can actually keep up with the pods, with the containers that we are provisioning. But guess what? It takes around 5 minutes in case of a cold start. Think about the journey of what's happening when you are scaling your infrastructure and you have more containers to run. It takes at least 30, 40 seconds to boot the Linux machine, right? There is an operating system that needs to start. Then there is kubelet that needs to connect this node into the cluster. Then we download the Docker image that we meant to run, and only then we can actually get to the stage where the actual application is starting. This whole process takes around 5 minutes, which is very, very long period of time, and that's why we see companies provisioning a lot of nodes ahead of time, so they will be there in case there is a spike in usage or any surge out there.
All right, so we understand the challenge. The question is, how do we actually solve this challenge? And we're happy to present today Compass, which is a Kubernetes platform that really tries to cost these efficiencies and make sure you can maintain those desired SLAs. So let's unpack this. All right, our approach to kind of tackling this problem has been looking into all the different components that drive up cost in Kubernetes: storage, memory, and compute. And basically building and tailoring automated solutions, emphasis on the automated solutions, because nobody wants to continue doing manual work, and make sure that this is served in one holistic platform. The core to this platform, and really core of our technology, and what makes it unique, is our ability to ramp up nodes in less than 30 seconds. Now, this is a game-changing. The fact that most nodes take around, like we said, average of 5 minutes means that you have to provision this additional overhead to make sure you don't experience downtime when a surge happens. And again, that's the reason why you have 70% unprovisioned, unutilized capacity in the cloud. And again, using Hyperscale and basically putting nodes into hibernation, preloading the images, and then very quickly ramping up when we need to, when we see a surge happens, is what makes us unique. And let's see how this core technology plays out across the different platforms and the different solutions. OK, so our first product, it's called headroom reduction. Headroom reduction, really what it tries to do is look at that unused capacity, that 70% unutilized capacity of nodes, and really make sure that we don't pay for that. And how do we do this? And we'll give you a demo after, like, in a couple of minutes, but this is an illustration of how this actually works. So what we do is we basically utilize and analyze the usage on your environment, on your cluster. We're seeing what is the steady state and what is the unprovisioned or like unutilized provisioned nodes. And we put those to sleep, and again, very easily. We put them into hibernation node. And then when a surge happens, and again, we're sitting there, and this is happening in real time, we start ramping up and taking these nodes out of hibernation state and making those active. So again, you only pay for that kind of utilized capacity. There is a storage component that you're paying for, but it's insignificant compared to the compute. So this is headroom reduction. I'll hand this over to Alexei to talk about other solutions.
Yeah, thank you, Hagit. And basically now when we understand the mechanics, right, we pre-provision instances. We're making sure we have everything that is needed in order for your containers to be up and running quickly. We actually use the same technology to help you utilize spot instances with much more confidence. Let me ask you a question. Any of you here using spot instances in your production? Nice, okay. I think those who hasn't raised their hands are actually concerned about the stability of spot instances, because as you probably know, spot instances offer very significant discount compared to on-demand, right? But AWS can take them and disrupt those instances with a 2 minutes notice. Now, as we mentioned, every single time there is a disruption of your spot instance, meaning there is a cold start, we need to provision a replacement node, and only then we can schedule our pods. So by having our hibernated and pre-warmed nodes, we can actually bridge this gap. So making sure that you have consistent amount of capacity in your cluster, even when spot instances are being interrupted. As you can see here, we're actually measuring each and every workload that you're running in your cluster, measuring the amount of time it takes for the node to boot up, the image to being downloaded, and the application to actually start serving requests and being marked as healthy. And we're squeezing this time to under 30 seconds in order to make sure that this application is actually suitable to be run on spot and can be a good candidate. As a result, we actually help customers to increase significantly their spot usage adoption, making sure we are driving around 70% cost reduction for those workloads, and actually making sure that the application is still stable and you can still have the same SLA as you had before. So everything that we mentioned right now, the headroom reduction solution and spot instances automation, is tools to help optimize your compute infrastructure. But what about the stateful applications out there? Right? We have some of the applications that require persistent storage and storing their state on the disk, or practically speaking, EBS volumes. It's called persistent volumes in Kubernetes. For those types of applications, we actually have a solution called storage autoscaling that provides you a real-time PVC management that can scale up and down dynamically according to the actual consumption of your pods. As you probably understand, behind the scenes there is an EBS volume that is being provisioned, which is a block storage that is super limited in its scalability. It can go up and down dynamically. You should come up with the size that is suitable for the workload. And again, we see the same issue once again. The utilization of the storage infrastructure is overseen, is also somewhere around 30%. So our way to solve this issue is actually by provisioning multiple EBS volumes, combine them into a virtual one, and this is exposed to your workloads as a virtual PVC. And now your application can consume this storage, and in case there is an increase in usage, we can simply provision one more disk, attach it to the existing pod, extend the file system, and make sure you have enough capacity to store your stuff. And vice versa is also true. In case there is a reduction and we don't need all of this capacity that is being provisioned, we use a copy and write technique to actually go and move any blocks that are left over on the disk we're trying to remove, reallocate them to the small volumes that are staying, and safely remove it. And by doing so, we achieve very significant savings on the EBS component as well. Back to Hagit.
Thank you. All right, so we talked about 3 automated solutions to help you optimize your journey in Kubernetes. To do all this, we actually have to analyze in real time and monitor your clusters. So we're monitoring CPU utilization, cost across your workloads and across your clusters. Everything we see, we also externalize in the product, so you can get a good sense of what's actually happening, what's your, basically give you visibility into your multi-cluster deployment. All right, so this is kind of a compass. I did promise you a very quick demo, so 1 minute demo even, to show you how the first solution, headroom reduction, actually works. So just to kind of explain very quickly about what you're seeing. So these are 2 clusters side by side. The right one has 6 nodes, the left one has 10 nodes. Both are running on Carpenter, and both are running the same workload. You can see on the right side, we have Zesty installed. In terms of graphs, what you're actually seeing, at the top you can see the number of running pods, that's the green line, and the red line is the number of unscheduled pods. So whenever unscheduled pods happen, we'll see errors. That's a spoiler for the demo. At the bottom, you can see CPU utilization. So for this workload, the steady state is around 10%-ish. So what we're going to be doing, and we're going to start running the demo, is we're going to make those equal. So we'll reduce the number of nodes on the left side to 6. So again, these are 2 equal clusters. And you see what happens when CPU utilization starts increasing. So here you go. On the left side, you can see that the number of nodes actually has been reduced from 10 to 6. So now these are exactly similar clusters, with, again, the right one running Zesty, both running Carpenter. We're going to start bombarding the cluster with requests to get the CPU utilization going up. So here you can see CPU utilization increasing. And on the left side, you can see that the unscheduled pods starts increasing. Whenever unscheduled pods happen, basically we can see errors happening. That's really failed requests, and that's what's impacting SLA and what's creating downtime or not a great experience for the user. On the right side, you can see that we had a 30-second period of unscheduled pods. That's the exact time it actually took us to get all these hibernated nodes into an active state. And immediately Carpenter starts scheduling these nodes, and they're available. So the number of failed requests on the right side, this is a live demo, and we all live pre-recorded demo, but we know what happens in live demos. OK, here we go. And on the right side, we can see that the number of failed requests was very, very... Sorry about that again. OK, let's just keep it like this. And you can see at the bottom side that the number of failed requests and the SLA was impacted, but not by a lot. And the significant savings were significant. And so again, just to kind of recap, on the left side, you can see about 5 minutes it took for a new node to get running, and then, OK.
It's not me.
OK, maybe they're trying to tell us it's a queue that we need to move on. OK, hopefully you got a sense of what Compass is. So again, it's a completely holistic platform trying to tackle both storage and compute challenges using our patented hyperscale technology and give you unmatched savings while maintaining SLAs. We're situated right across from this aisle, so we're over there at booth 427. We would love for you guys to stop by if you have additional questions. If you want to talk to our engineering team and learn more about what's happening behind the scene, we would love to, or just see a live demo, an actual live demo without interruption. Thank you again for the time, and have a great day.
Thank you.